So here are the notes for 1.5. So this is a graphing calculator activity, and what we're going to do is use a graphing calculator to find the zeros of a function. Remember some other names for the word zeros. We have X-intercepts, we have roots, and then we also have solutions. So basically, we're going to be able to use the graphing calculator to find the x-intercepts on a graph. And then we can do the same thing to solve word problems as well. Okay, let's go ahead and get into the notes. Now, at any time, if I am going too fast, make sure you pause the video so you can kind of get caught up. And then if you have any questions, make sure you come in before or after school to get some help. And then you can also email me. Okay, let's get into it now. Okay, so here we have solve the quadratic equation using a graph. Basically, they're saying you solve the quadratic equation by using a graphing calculator. Now, before, right, we have already learned how to solve quadratic equations by factoring and by taking the square root on both sides and by completing the square. So basically here, you could use any of those. I think this one, though, you would not be able to factor, because if we think of all the numbers that multiply to 6, so 1 is 6 and 2 and 3, none of these would actually add up to a 3. Also, we probably would not take the square root of both sides, because notice there's 3 terms here, right? So whenever you take the square root of both sides, usually there's no x term. So really what you could do is use completing the square to solve this. In this case, we're actually going to use the graphing calculator, okay? So let's go ahead. Now, when you're doing the graphing calculator, you do have to show some work. Now, the first thing to do to show work is we're going to plug this equation into our y equals. We're going to plug it into the y1. So the first thing you need to do is identify your y1. So that's the y1 equals x squared plus 3x minus 6. Now we're going to actually plug this into our graphing calculator. So remember, to get into our graphing calculator, to get the y, we go to our y equals button. So we're going to go ahead and press that. Then we're going to plug in x squared plus 3x minus 6. Now remember, the x is right next to alpha. Then we do squared. You do minus 6x. Sorry, that should be 3x. So minus 3x, and that really should be plus. So x squared plus 3x, there we go. And now I'm minus 6. I was getting ahead of myself there. So we plug in x squared plus 3x minus 6. Okay, now we're going to graph. So we're going to press the graph key, and we're going to look at our graph. Now remember, we're finding the x-intercept, so where it crosses the x-axis. Notice that we have 2 solutions here. So we're going to be doing this, using the information here twice to find our answer. Now, at any time, if you want to get it, your x and y axis in standard form, remember you can always go to zoom and then go to number 6 for z standard. That gets your graph for the x and y axis to be from -10 to +10. Okay, now the next thing to show work here is we do have to sketch this graph. So notice kind of where the x-intercepts are. One of them, if we count 1, 2, 3, 4, it's between -4 and -5, okay? Our other one's between 1 and 2. So when we sketch this graph, we're going to have it just in between those 2 values, okay? So I'm going to do this with our blue here. So we have 1, 2, I'm just going to do 3 on this side. I need 1, 2, 3, 4, and 5, because remember it's between those 2. Okay, so remember one of them was between 1 and 2 on our x, and the other one was between -4 and -5. And then here we just sketch it. Boom. I know this kind of looks wider than what we have, but remember, this is a sketch, so it doesn't need to look perfect. Okay, so now what we're going to do is actually find each of these x-intercepts. So what we're going to do is we're going to go to our second trace. So you're going to press the second button and then the trace. We're going to go down to number 2 because remember we're trying to find our zeros. Okay, so you press 2 and then enter. Now just like when we did min and max, it's going to ask you for left bound and right bound. Now this is going to be different because you're finding 2 different solutions. So let's maybe talk about this x-intercept on our left hand side. So let's talk about what left bound, and it's going to ask you also about right bound, what those really mean. So I'm going to go back to our sketch and kind of talk about that. Okay, so it's asking us for a left bound. Now how can we decide what is our left bound of an x-intercept? When we did our vertex, it was pretty simple. Left is on the left-hand side of the vertex, right's on the right-hand side. Now, what I would suggest is drawing a line right through your x-intercept. Just a straight line. It doesn't have to be dotted, but I'm just going to do that. It can be solid. Now, when it asks us for the left bound, what we want is the left-hand side of our x-intercept. That's why I drew this line, because we kind of can decide, well, what's the left-hand side and what's the right-hand side. So we notice the left-hand side of our x-intercept on the left over here, that the left bound is anything above the x-axis. Okay. So that means when I put this in my graphing calculator, when I do the cursor, I just need to make sure that the cursor is somewhere above the x-axis because that's on the left-hand side of the x-axis, or of our x-intercept. Okay, going back to our graphing calculator, so see the blinking light? That's our cursor. Now you can only move the cursor using the right and left arrows. So what I need to do, because we're trying to find this x-intercept, is I need to move the cursor above, just somewhere, and it does not matter, just somewhere above the x-axis, because that's going to be the left-hand bound of our x-intercept. Okay, now once you've done that, make sure you press enter. Now what we need to do is right bound. So that means we need to do the right-hand side of our x-intercept. So I'm going to go back to our sketch to decide what this is. Okay, so right-hand side, it seems like anything that's below our x-axis. Now, we don't want to get too close to the vertex, so that's what is going to be changing here. We want something that is below the x-axis, but not too close to our vertex. So just something right here. Now remember, it does not matter where you place it, right? Just make sure for now, because this is the right hand, it's going to be below the x-axis, and then just somewhere between our x-intercept and our vertex. So now, on our graphing calculator, going back to that, I'm going to move my cursor somewhere down below the x-axis, and it has to be between the x-axis and our vertex. We don't want anything over here, because then we're not talking about this x-intercept. So to do that, I have to use my right arrow to do that. This looks like a good spot. Now I press enter. Now remember, for the guess, you press enter one more time so we can get the correct answer. So here for our x, we get -4 point. Now you can see we have decimals, so we'll just round to 2 decimal places. I think that'll work best. So we'll say our x value is -4.37. Now if you notice here, we have -1e to the -12th. What this e to the -12th means is that you're moving the decimal, and because this is negative, to the left 12. So let's say we had -1 and we move that decimal over to the left 1. Well, if that was occurring, right? Well, this value seems like it's getting very close to 0. So whenever you are finding your x-intercepts, your y value will always be 0, even though it might not say on the graphing calculator. The graphing calculator is actually more accurate in finding these zeros than when we actually just do it by hand with completing the square or with taking the square root on both sides. Okay, so our first x-intercept is at negative 4.37. So let's go ahead and write that down for our answer. And then know that for this is also how you would write the x-intercept as an ordered pair. Okay, so here's just saying x equals, and then this is our ordered pair. Okay, now what we're going to do is the exact same thing, but now for our second x-intercept. So to do that, I'm going to go back to the graphing calculator. And once again, I'm going to press the second to the blue key and then the trace. And I'm going to go down to number 2 for 0. And I'm going to press enter. Now, what we want to do is find the left bound of now our second x-intercept. So it's all the way over here. In order to know what is the left bound, I'm going to go back to my sketch and draw another line. Okay, so I'm going to draw a line now through this x-intercept. Okay. And now, remember, left means the left-hand side of the x-intercept. So now our cursor is not going to be above the x-axis this time. It's going to be somewhere below, because this is the left-hand side of our x-intercept. So it kind of has changed a little bit. So that's why I highly encourage you to draw this line so you definitely know what's the left-hand side and what's the right-hand side of our x-intercept. So that means we're going to move our cursor somewhere in between the vertex and then somewhere below the x-axis. So we want to have our cursor in between the vertex and the x-axis. Okay, so remember, you can only move the cursor using the right and left arrows. I'm going to use the right. And so this seems like a good spot because it is between the vertex and the x-axis. And then I press enter. Now to find right bound. So that means we got to find the right-hand side of our x-intercept. To do this, I'm going to go once again back to my sketch here. Now the right-hand side seems like anything that is above our x-axis. And then remember, it does not matter where you put it. It just needs to be somewhere on the right-hand side. So somewhere that is above the x-axis. So I'm going to place my cursor there. So once again, I'm using my right arrow to move it over, and I have to go above the x-axis. And now where my cursor is at, it is above, and I can press enter. And then whenever they ask guess, press enter one more time. So you basically press enter 3 times. So notice here that our x-intercept, which is between 1 and 2, we have 1.3, and I'm going to round to the 2 decimal places, so we have 1.37, and then our y value is 0. So our second x-intercept, or 0, is 1.37. And then if you want to write that as an ordered pair, you would do it you would do it as 1.370. There you go. So if you're wondering, well, what work do I need to show if I'm using the graphing calculator to find the x-intercepts? Well, what you need to show is 1, the y1 equals your equation. Number 2 would be the sketch of the graph, and I highly recommend using these lines to determine your left and right bound. And then number 3, you need to have your answers. Okay? So 1, 2, and 3, that's everything you need to show for the work-wise. Okay, now let's go ahead and apply this to a word problem. Okay, so dropping an object. Now we've talked about this, especially in section 1.5. This is also 1.5. We've seen this formula before. H equals negative 16t squared plus h naught. Remember, h represented the total height, which was in feet. And then we had negative 16t squared, where t represented time. And your h naught represented the object's initial height. So where initially you dropped the object. Okay, so this is basically the same exact example we've done before. So here it says for a science competition, students must design a container that prevents an egg from breaking when dropped from a height of 50 feet. How long does the container take to hit the ground? So what we need to do is plug in values in for h and h naught, because we are solving for t. So that means we are solving for our x-intercepts here, okay? Now remember, the height of 50 feet, that represented our h naught, and the ground was 0 basically. So here we had 0 equals negative 16t squared, then plus the 50. Now the last time we solved this, we basically moved the 50 over, and then divided by negative 16, and then took the square root on both sides to get our answer. Okay, so I'm going to do that again to see what we get, and then hopefully when we do using the graphing calculator, we get the same answer. So remember, we subtract 50, so I have now negative 50 equals negative 16t squared. Then I divide both sides by that, so I get t squared equals. And then make sure you can plug that into your graphing calculator to get that answer. So let's go ahead and do that. So we have negative 50, oops, let me get out of this note, there we go. Negative 50 divided by negative 16, which we get 3.125. And then we take the square root of it. So when we do that, we get t equals, let's go ahead and plug that into our calculator to see. So we do square root of 3.125. Yep. And we get this long answer. Let's go ahead, let's just round to 2 decimal places like we've been doing. So we have 1.77 seconds. Okay. So now what we're going to do is actually use the graphing calculator to see if we get the same exact answer. Now in this case, when we're showing our work, we're not going to have the 0 anymore. So in order to plug it into our graphing calculator, we have to have y equals negative 16t squared plus 50. So I'm going to show my work on the next page here. So instead of having 0, we're going to have y, and then we have the 1, because that's what we're plugging into our graphing calculator, negative 16t squared plus 50. So all I did was rewrite it and replace the 0 with the y1, so we can actually put it into our graphing calculator. Okay, let's go ahead and do that then. So remember, go to y equals, and then here I'm going to clear this because we don't need it anymore, so you press the clear button. And then we have negative 16. Now, in this problem we're using t, but you can also use x. They all really mean the same thing. So I'm going to use the x button here, and then square it, and then plus 50. Okay, let's go ahead and graph this. Ooh, that looks very interesting. Okay. Now here, just like we've been doing, we see 2 of our x-intercepts, right? But because this is a real-world problem, and remember last time we only got 1 solution, we're not going to use the negative x-intercept because it wouldn't make sense, because remember this horizontal axis represents time. It would not make sense to have negative time. So really all we're wanting is this area over here, okay? Now in this case, you can change the window if you want to make it a little bit wider. If you are wanting to do that, I'm going to show you next. Or you can just leave it like this to find the answer. Both will get you the same answer. Now I'm going to change the window just because all I'm wanting is this side of the graph to get my x-intercept. So that means I'm going to start from 0 and then move on over this way here. Okay. So I'm going to have go to window. This is where you can change things. So my x-min, remember x is your horizontal is -10. I'm going to change that to 0 here. And then my x-max is 10. Now if I notice, I already saw my x-intercept, so that seems good. Scale, that's how much I want to go by. 1 seemed fine to me. And then we have -10. So there, that was our bottom part. That seemed fine. But notice on our graph that we couldn't really see the vertex. Now I'm going to show you how to change it. Now this might just take some trial and error when you're trying to figure out the window. So let's just see if we go up to 60 if we see the vertex. Because you might want to use this if you're trying to figure out the max and min. So scroll all the way down using your down arrow. Let's change this to 60. And because of that, I'm going to change my scale as well. So my y scale, I'm going to change it to 5. So that means that on my y-axis, it's going to go by 5s instead of 1s. Okay, now I press graph again just to see. So we can kind of see a little bit better here, right? Okay, so what I'm going to do, remember we have a y1. To show more work, I'm going to show this sketch. Now notice we went by 1s on our x, so our answer is between 1 and 2. And then we have our y up here. Now remember, I went by 5s. Okay, so this is 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So this y-intercept, remember y-intercept means crosses the y-axis, that is at 50. So I'm going to go ahead and draw that. I'll change it to blue here. So I have here and then here. Now remember, I didn't have this other side of the graph because we would get negative time, which doesn't make sense in a real world problem. Okay, I'm going by 5s on my y value, and that's why I put 5 just to indicate that's what we're doing. And I'm going to put 10 to show that as well. Okay, so 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And then here we go by 1. So I'm going to have 1, and then 2, and then I'll just do 3 over here. Okay, so we start at 50, which was all the way up here. And our x-intercept's kind of between. Now we actually already know the answer because we got it last time. It was 1.77. But we're using the graphing calculator to see if this is actually true, because it will give us a better representation. So here's our sketch. So remember, for work, put your y1 in your sketch. Our next thing is to actually find the x-intercept. Now, to do that, going back to our graphing calculator, we go to second and then the trace key. Now remember, we're finding 0, so we go down to number 2 and enter. This is where we get into our left and right bound. Now, to understand what's our left bound and our right, we're going to go back to the sketch, and we're going to draw our line here. Okay. So the left-hand side of the line will be our left bound. The right-hand side of our graph is going to be our right bound. Our right-hand side of the line will be our right side. So we notice our left-hand side seems like it's above the x-intercept. So here's the left-hand side. It is left of our line, and it's left of our x-intercept. Okay, so we need to just make sure our cursor is somewhere between our y-intercept of 50 and then our x-intercept. So somewhere right in between here. Okay, so what I need to do is move my cursor. Now notice where my y is, that's why you can't see the cursor, so I'm going to go and make sure I can get it. And basically you just want to keep using the right or left hand arrows until you see it. Oh, there it is, it's blinking. But remember, we need it somewhere above the x-axis. So this is our left bound, I'm going to press enter. Now our right bound, let's see where that is at on our graph. It seems like it's anything that is below the x-axis. So we just need to make sure we put our cursor anywhere that is on the right-hand side of that line. Okay, so I'm going to go back to my graph. There we go. And then remember, you got to only use the right and left hand arrows to move the cursor. So I'm going to do that. And there's my cursor below. I'm going to press enter. Remember, guess you press enter one more time. And notice here, we get the same answer. We get 1 point, and remember we rounded to 2 decimal places. There should be 1.77. Okay, so that means our X-intercept, our answer, would once again be X equals 1.77. So there you could use both, taking the square root of both sides, or use the graphing calculator to find that answer. Okay, if you have any further questions, make sure you come in before or after school to ask them, or email me. I know this is a little bit difficult, and it just takes time to kind of be working on your graphing calculator to do so. Okay, don't forget to do the homework. Oh my gosh, my leg is killing me.